In 1971, a young programmer sat at his computer terminal, completely unaware that his next few keystrokes would change the digital world forever. What he created wasn't meant to be malicious. It was an accident that would birth the first computer virus. This is the story of how a simple experiment in self-replication turned into the ancestor of every computer virus, worm, and malware that exists today. A mistake that would spark a digital arms race lasting decades. Meet Bach Thomas, a programmer working at the research company BBN Technologies. It was an era when computers filled entire rooms, and the internet was just a dream called ARPANET, connecting only a handful of universities and research facilities. The year was 1971, and computer security was virtually non-existent. Passwords were rare, firewalls didn't exist, and the concept of malicious software was pure science fiction. Trust was the foundation of the early computer age. Thomas was fascinated by a theoretical concept he'd read about: self-replicating programs. Could he create a piece of code that could copy itself from one computer to another? It seemed like an interesting programming challenge. Working on the ARPANET system, Thomas began coding what he called the creeper. It was meant to be a harmless experiment, a program that could move between computers connected to the network, leaving a simple message behind. The creeper program was designed to do three simple things: copy itself to another computer on the network, display a message saying, "I'm the creeper, catch me if you can," and then delete itself from the original machine. Thomas wrote the code carefully, testing each function. He wasn't trying to cause harm. He was simply exploring the boundaries of what was possible in this new interconnected world of computers. On that fateful day, Thomas executed his program. The creeper came to life, immediately copying itself to another computer on the ARPANET. For the first time in history, a self-replicating program was loose in a computer network. At first, everything seemed to work perfectly. The creeper moved between computers, displayed its playful message, and deleted itself as designed. Thomas watched in fascination as his creation traveled through the network. But then something went wrong. The creeper began behaving erratically. Instead of cleanly deleting itself, copies started accumulating on some systems. The program was multiplying faster than it was disappearing. System administrators across the ARPANET began noticing unusual activity. Strange messages were appearing on their screens, and some computers were running slower than usual. The first computer virus had been born. Thomas quickly realized his experiment had gone beyond his control. The creeper wasn't just moving between computers, it was reproducing and spreading in ways he hadn't anticipated. The ARPANET, which connected only about 20 computers at the time, was experiencing its first taste of what would later be called a computer virus. The term virus wouldn't be coined until years later, but the concept and the fear it inspired could be traced back to that day in 1971. Unlike modern viruses designed to steal data or cause damage, the creeper was relatively benign. It didn't corrupt files or steal information, it simply announced its presence and moved on. But it had crossed a crucial line. Word of the creeper spread quickly through the small community of computer researchers. Some were fascinated by the technical achievement, while others were concerned about the implications of self-replicating programs. Thomas tried to contain his creation, but the creeper had already demonstrated a fundamental truth about networked systems. Once something starts replicating, it can quickly become impossible to fully control. The solution came from an unexpected source. Another programmer, Ray Tomlinson, who would later invent email, created a program called the Reaper, specifically designed to hunt down and destroy creeper copies. The Reaper was the world's first antivirus program, though nobody called it that at the time. It would search for creeper infections, remove them, and then delete itself. It was a digital immune system in action. The battle between Creeper and Reaper played out across the ARPANET for weeks. It was the first cyber warfare, albeit a gentle one between programs that were more curious than malicious. Eventually, the Reaper succeeded in eliminating most creeper infections. The immediate crisis was over, but the implications were just beginning to be understood. The age of computer viruses had begun. Thomas had inadvertently opened Pandora's box. His innocent experiment proved that self-replicating programs could spread through computer networks, inspiring both legitimate researchers and malicious hackers. The Creeper incident taught the computing world its first lesson about network security. It showed that interconnected systems were vulnerable in ways nobody had previously imagined. In the years that followed, the techniques pioneered by the creeper would be refined and weaponized by malicious actors. What began as an academic curiosity would evolve into a billion-dollar cybersecurity industry. The term computer virus was coined by researcher Fred Cohen in 1983, more than a decade after the creeper incident. But the concept and the fear it inspired could be traced back to that day in 1971. Thomas never intended to create something harmful. He was simply exploring the boundaries of what was possible with self-replicating code. His mistake was not considering the unintended consequences of his creation. The creeper virus was remarkably sophisticated for its time. It demonstrated concepts that wouldn't become common until decades later: network propagation, self-modification, and autonomous behavior in distributed systems. Modern cybersecurity experts study the creeper as a historical artifact. It represents the moment when the computer age lost its innocence and began to grapple with the dark side of connectivity. The principles behind the creeper live on in modern technology. Today's software updates, cloud computing, and distributed systems all rely on programs that can replicate and move between computers. But the creeper also inspired generations of malicious software. Every virus, worm, and piece of malware that has ever infected a computer can trace its conceptual DNA back to that first accidental creation. The cybersecurity industry that exists today, worth hundreds of billions of dollars, exists partly because of what Thomas unleashed that day. His accident created an entire field of human endeavor. Thomas's story reminds us that in the world of technology, even the smallest actions can have enormous consequences. A single program, written as an experiment, changed the course of computing history. The creeper incident also highlights the importance of responsible research. Thomas was working in uncharted territory, but he could have taken more precautions to contain his experiment. Today, researchers working with potentially dangerous code use isolated environments, careful testing procedures, and extensive peer review. The lessons of the creeper incident have been learned. The creeper virus holds a unique place in computing history. It wasn't malicious, it wasn't sophisticated by modern standards, but it was first. And in technology, being first often means changing everything. Some historians argue that the creeper incident accelerated the development of computer security by decades. It forced the computing community to confront vulnerabilities they hadn't yet imagined. The phrase, "I'm the creeper, catch me if you can," became legendary in computing circles. It was playful, almost childlike, but it represented something profound: the loss of digital innocence. Ray Tomlinson's Reaper program was equally groundbreaking. It established the concept of using software to fight software, a principle that underlies all modern cybersecurity. The early computer age was characterized by trust and openness. The creeper incident marked the beginning of the end of that era, ushering in an age of digital suspicion and security measures. Today's internet, with its firewalls, antivirus software, and complex security protocols, exists partly because of what Thomas learned that day: that in a connected world, every action can have unintended consequences. The creeper virus taught us that the same technologies that can benefit humanity can also be used to harm. It's a lesson that remains relevant as we develop AI, quantum computing, and other powerful technologies. Thomas's accidental creation reminds us that we live in an interconnected world where a single mistake can have global consequences. In the digital age, there are no isolated actions. The story of the creeper virus is ultimately a human story, about curiosity, unintended consequences, and the responsibility that comes with creating powerful technologies. From a simple experiment in self-replication came an entire industry, new fields of study, and a fundamental change in how we think about computer security. Thomas had no idea what he was unleashing. The first computer virus was born not from malice, but from curiosity. It reminds us that the most significant discoveries often come from unexpected places, and that innovation always carries risks. Today, as we stand on the brink of new technological revolutions, the story of the creeper virus serves as both a warning and an inspiration. It shows us the power of code to change the world, for better or worse. The programmer who accidentally created the first computer virus gave us more than just a piece of malware. He gave us a lesson in responsibility, the importance of security, and the reality that in our connected world, every action has consequences. If you found this story fascinating, hit that subscribe button and the notification bell for more incredible tech stories. Like this video if you learned something new, and share it with anyone who loves computing history. What other tech stories would you like to hear? Let me know in the comments below.